Hi everybody, welcome back. Thank you for tuning in. We just released our video last week, 3-axis to 5-axis, and we're going to give you a little bit of a rundown, some of the details on how we put this video together, and we're going to address a lot of the comments that we got in the comments section. Got some great stuff, and we want to give you feedback on the feedback you gave us.
So one of the things we want to address right up front is we did not purposely choose this part so that all the numbers would look good and we could sell more UMCs. Tell everybody why you chose this part.
Yeah, I chose this part because we needed something that had machined features on multiple different sides. It's no good to take something you could machine operation 1, flip it over, machine operation 2, and you're done, right? So it needed features on many different sides, and I saw this triangular part and thought, oh, that'll make a really good demo part. I modeled it and started working on the 5-axis first, and then we decided to do the comparison video, and I thought, well, this will be a perfect part. Let's see how we would make this on a 3-axis machine.
So why don't we talk about how you chose to hold the work part of the work piece?
Yeah,
in the 5-axis machine.
So on the 5-axis, we started with this block, and I had really two options. I could hold it on this side and hold it on this side. Now we had an interesting comment from somebody on the video that said, why didn't you cut the blocks into triangles? And frankly, that thought hadn't even occurred to me. And thinking about it a little more, it would be more efficient in roughing, but I still wouldn't be able to hold the stock on that triangle side and finish this because I'd have to get rid of that stock, and this would be an awkward orientation to hold the part for the second operation, which would be on the side of the trunnion there.
So it was really long side versus short side.
Yeah, long side versus short side, exactly. And frankly, the big worry that I had holding it on this side and having all this material sticking out was that this thing would be out there flapping in the breeze and set up too much vibration and cause problems like that. So, so really, the only, in my mind, the only feasible way to do this was to hold it on this side and then lean it down. Actually, we started with establishing this plane and then roughing all of the material, turning the rectangle into a triangle there.
That's probably part of why you maybe didn't think about cutting it in triangles to begin with, because that's a very typical way to just deck something down quickly.
Yeah, I knew I had the easy in the 5-axis operation. Use the 3-axis face mill to cut all that material off, and I made a real efficient tool path that just cut the corner and then went a little wider and a little wider, and you know, I think was very efficient at removing all that stock.
So for talking about holding the part, obviously that's the type of vise that you used, a self-centering vise.
Yeah.
Before the video, we had a little debate. Well, it wasn't really a debate. You're making the decisions here, but on whether we hold the stock on the serrated jaws or if you're going to use a dovetail.
Right. So the Haas self-centering vise that I was using has a 45-degree relief. It's not technically a real dovetail, but it does have that 45-degree angle. And I decided that I was going to use a dovetail cutter to put a slot on the material and then grab it. So not only did I have the serrations gripping into the material, but I also had
that mechanical lock.
Yeah, I had that angle underneath to give me a little extra security that I wasn't going to pull that material out of the vise. That was the main thing that I was worried about, because I knew I wanted to rough this part very aggressively, and you know, I didn't want it to come out of the
So if you didn't have that, you'd have backed down your roughing. If you're
maybe,
just holding it.
Maybe, we'll
potentially.
see. Yeah.
But it's something you didn't have to worry about anymore.
I probably would have tried it, and if it came out, then I would change course.
Yeah.
So if we sold a dovetail, would you have chosen differently?
Oh, yeah. I think I would have used the dovetail jaws for the manual self-centering if we had those available. Now, I could have taken the soft jaws.
So you would have gripped in a smaller area then?
Yeah, so the benefit of the smaller area dovetail, there's a benefit and a drawback to it, right? But the benefit is that you don't, that all the sides of the material overhang the vise. So you could bring a cutter, a face mill for instance, and cut all the way off of the material. So you don't have to worry about running into anything. That's a really nice thing. But the drawback is that it requires a whole nother operation. You've got to face it off, you've got to cut the dovetail, you got to deburr the dovetail, and if your dovetail fixture actually has a locating slot in it, you got to cut that slot as well. So there are benefits and drawbacks to doing it both ways. I found it just as easy, and my starting stock that came from the mill in 2.5 by 3.5 gave me enough stock to hold on to without causing interference with my cutting tools.
So in this case, you in the video you talk about leaving that small land there still, and having to be very careful about how closely you approach the vise. So did you do that only in cam or to check clearances?
Yeah. So in cam I brought in the model of the dovetail and the riser. And I brought in the model of some of the key cutting tools that were going to get close to the vise that I knew about. So I modeled everything and obviously watched it very close. But I did run into a problem, something I didn't anticipate. And that is the chamfer tools and the 1/4-inch end mill that get all the way down inside of this pocket. I didn't run into a problem where the cutting tool was going to hit the vise. I actually ran into a problem where the nose of the spindle of the machine was going to run into the side of the casting, to actually the rotary table itself. So that was something that, as I was running the first part in there, I had to go slowly and watch and make sure everything was clear. And it became pretty clear when that tool started getting near the part that it was not going to make it. So I just took my chamfer tool and my 1/4-inch end mill and put those in a longer ER collet chuck that I mentioned in the video. Those were only $4 more than the shorter ones. So it wasn't financially, it wasn't a big hit or anything. It's just one of those things that happens with 5-axis. You need longer cutting tools to reach the material.
And we were actually just talking about that, where conventional wisdom is you keep your part as close to the table as possible, right?
Yeah.
And when you go to a 5-axis, you got to rethink that, because you got to tilt that part over on the side and be able to reach it without your spindle hitting the platter.
That's why this vise is sitting on a riser. It's 100 millimeters, about 4 inches above the table, and that's to get the workpiece farther away from the rotary so that when it rotates sideways, you've got more clearance. Your cutting tools are here instead of right up next to the rotary table itself. Also, it's really easy to get the workpiece on the center of the rotary table, right? We're doing work in all kinds of orientations around this part. You don't want your part way off center on the rotary table, so when it rotates around, you've got this large distance. And by the way, if you needed to cut something down here at bottom, now you have a long way for your cutters to go. So you always want your workpiece to be close to that center of rotation, and that's the benefit of using the self-centering vise with the riser.
Right.
Another reason you're not going to typically have something like a 6-inch backstop vise on one of these machines.
Yeah,
it's too low, and it's also
too low, right.
It's just not kind of configured as to make it as easy to set it
Right. As a matter of fact, if you were trying to get the workpiece to be in the middle, the center of that rotary table, you may end up hitting the trunnion with that big 6-inch fixed jaw vise.
Fixed jaw vise, right. So, okay, we talked about work holding a little bit. We talked about tools a little bit. One of the big, I think, obstacles in people's mind about going to 5-axis is programming. And as you pointed out in the video, the programming is not a lot different.
Yeah, so the main difference in programming for the 5-axis machine over the 3-axis machine is really setting up tool planes. And research has shown that only about 5% of all 5-axis work is actually simultaneous 5-axis tool paths. The other 95% is what we call 3+2 machining, where the part is held, it's rotated to a fixed position on the rotary table, and then you do 2.5-axis machining on that part, rotate it to another position, and do the same 2.5-axis machining. So the real difference is establishing tool planes, right? Is my tool going to be coming in from this angle? Is my tool going to be coming in from this angle? Is my tool coming in from here? Whatever that is, establishing the tool plane is the only thing that really makes it different from programming for a 3-axis machine. Once you've got it in that tool plane, you're still doing your X, Y machining and dropping down in Z. So it's really not that difficult to transition from programming for a 3-axis machine to programming for a 5-axis machine.
It's funny that you mention that doing full simultaneous 5-axis on these machines is really the exception, and typically it's 3+2, because one of the viewers commented, graphics by George said, 5-axis simultaneous for the Insta-likes, 3+2 for the money. And that's really what it comes down to,
Yep.
right?
Absolutely.
And that's a little bit of why, there was a lot of comments about how this machine was maybe overkill for this kind of a part.
Yeah. Why would you make this part? Why would you take up time on that 5-axis machine to make this part? Well, I got news for you. You may not have really complex 5-axis parts to run on your machine, and it's better to run a part like this than nothing at all.
If this can still be more efficient, then it still makes sense. To
Yeah,
do it.
absolutely. Absolutely.
Yeah.
It's still more efficient, as we proved with the video, to make this part in this machine over a 3-axis machine.
And I guess let's go ahead and address the elephant in the room. And we got a lot of comments about the cost of the 5-axis machine versus the 3-axis. And obviously we're well aware of that. The point of the video, again, going back to why we did this, was, are you better off making a part on a 3-axis or a 5-axis? And yes, the machine's more expensive, but the 26% cycle time savings, whatever your shop rate is, however that ROI works out, what you determined was it's much more efficient to make the part on this machine.
Yep, and that time is money. Right. So ultimately, this machine is paying back its investment.
I think that we were going to probably talk about this later, but we could probably just throw it in now. There was a bunch of comments about making this part on a VF4SS or something similar with a 4th-axis rotary table installed. And we didn't set out to make that comparison here, but it's a perfectly legitimate way to do this part. Or several other people mentioned doing it on a VF4 with a TRT, with some kind of trunnion, a TR, TRT, something like that. And that, in the end, you end up basically making it the same way as you're going to do it here.
Yes, exactly. So I'll address those two separately. But first, 4th axis, definitely. This part could be made easily on a 4th axis. Yep. It would be the same operations and the same setup that I did on this 5-axis machine. I would probably use the same riser and self-centering vices I did here, but put it on the 4th-axis rotary. The only thing you'd have to change is your roughing strategy for the material. I roughed it in this orientation to get it to the triangular shape. You could still do all of this with a face mill, very similar tool paths to what I did in the 3-axis machine when it was held in that 4th-axis orientation. So definitely a perfectly legitimate way to do this part. Probably be way more efficient than the 3-axis machine. Maybe not as efficient as the 5-axis setup. We'd have to really get into the nuts and bolts, but yeah, that's a legitimate way to do it. And the other commenter who mentioned I would put a TRT 210 on that VF4SS and make it there with on that machine with a vise on the side, that would be perfectly legitimate too. Basically, exactly the same thing as I did.
Yeah.
Right.
Yeah. And cost-wise, machine cost-wise, it's about the same.
Yeah, the VF4 with a TRT 210 is within 10 grand of this machine.
Yeah.
Right.
And believe it or not, I mean, a VF4 with an HRT 210 and everything else that you need to set that up, you're over 100K at that point. So it isn't like you get 2 of those for one of these.
Right.
It isn't less expensive. And you do get some benefits from putting a TRT or an HRT on here. You get the big table still if you want to just do 3-axis work, you take it off.
Right.
For sure.
Yep.
And I don't think we're not trying to hold any information back. You can easily see all the prices of these things on our website. So,
again,
mostly we're just trying to give you a comparison of these two methods.
Yeah, we've had a lot of people over the years say, man, I'm interested in 5-axis, but I'm not sure if I'm ready for it. And that's really what we wanted to address with this video.
Yeah. Yeah.
We also got a lot of comments about your work holding choices and the fact that on the 3-axis you had 5 vices, and you had some, when we talked off camera, you had some responses to that.
So yeah, those comments were saying that it wasn't fair to add the cost of the work holding into our cost comparison. And maybe not. Certainly you're going to amortize the cost of those vices over the life of the vice. But if you didn't have all of those vices and you needed to set this job up, you had to go buy them, right? That was a legitimate cost. And you also paid for the work holding over here. That's why we compared both, the cost of both. But also in the 3-axis machine, let's say you did own 5 vices, but you owned 5 vices. Now, none of your other machines can have a vice while you're running this job. So that's another drawback to using 5 vices at the same time in your machine.
Okay, so on the theme of work holding, one of the big considerations was tear down and setup time, right?
Yeah.
So we got 5 vices, whether you own them or not, or you got to buy them, you got to put them on the machine.
Yes. So several of those vices had custom jaws that I had to make, and I was able to make them on the vice on the machine, so setup was pretty easy. They were already lined up because I machined them right there. But tearing that job down and setting it up a couple of months later when you get that job again would be a lot more difficult on that 3-axis setup, because all those vices would need to be dialed in, and you'd have to get your vice jaws reinstalled on the vices and get everything lined up and flat. It would definitely take you longer than the time that I calculated it took me to set that machine up to begin with. So reset up on the 3-axis machine would be very lengthy. On the 5-axis machine, it wouldn't be bad at all, because essentially with the dynamic work offset and tool center point control feature on the UMC 500, you put the vice anywhere on the table. It's generally in center, bolt it down, tram in the vice so that it's perpendicular to the x-axis, and call that C0 in your work offset. You're done. Set your tool lengths, pick up your work offsets on the part, and you're done. There's no alignment that's critical. It's just using the rotary table to get the vice parallel to the x-axis.
Right.
And then on the side vice, you might have a little bit more of that, but essentially it would be just getting the vice set so it was parallel to the x-axis and also flat in the z-axis, which you could take a skim cut to reestablish the flatness if it wasn't there when you set it up to beginning. But just off the top of my head, I would say you'd save an hour, maybe 2, resetting up on the 5-axis versus resetting it up on the 3-axis machine.
All right, so along the lines of setup time, when we were first talking about doing this video, way before we started shooting, we had also considered, what's the approach to the shop with VF2, with the smaller machines, how do they approach this?
Yeah.
And then you start getting into problems of potentially having operations on more than one machine. So maybe talk about that.
Yeah, so if you had a VF2, you definitely would not have the ability to, in my opinion, wouldn't have the ability to do it all, put a part in, have it machine, get one part off complete at the end of one cycle. You would have work in process. You'd have to do, I'm assuming, 2 vices, do operation 1 and 2, and then once you did that operation 1 and 2 on all the parts, then put 3 more vices up there, change the jaws out, and run operations 3, 4, and 5 through the rest of the work.
So then, that's going to take even longer because you've got teardown between your 2 setups.
Yeah. Now your setup is fewer vices, but you're still having to do a changeover. So I'm not sure exactly how that would play into the total time, but I got to imagine that it's going to take longer to machine the parts that way than to have all 5 vices set up in one operation.
Yeah, and that kind of speaks to something that we noticed in the comments as well, is kind of, we approach this from, on this machine, you put a part in, you get a part out. You put a part in, you get a part out. And you set up the VF4 to do the same thing. So you've got one piece flow in there. So you aren't doing op 1 on 5 vices and then op 2 on 5 vices, and you don't have a pile of work in process sitting beside your machine. You're doing 1 in, 1 out.
Right.
And then you're stair stepping each part through each set, through all the vices.
Yeah. I did want to mention that when I made a program for Operation 1, and it called all the tools for Operation 1, and then there was another program for Operation 2, and it called the tools and did that, and that made setup really easy because I ran a part all the way through Operation 1. Now I had to finish part 2, load into the custom jaws for Operation 2. And it could have reduced a little bit of cycle time if I would have set it up where Tool 1 came in and did all the work on each five vices
right.
or whatever that situation was. But that was going to take a ton of extra time because I couldn't just run a part through on Operation 1. I would have to stop my program and run. The setup would have been a nightmare to do it that way.
To get your starting set of 5 parts.
Yes, to get my starting set of 5 parts. And I actually did the calculation. Doing it the way I did it, I had 12 extra tool changes. I didn't have any more machining operations. I just had 12 extra tool changes. The average chip-to-chip time, I think the specification on the VF4SS is 2.5 seconds chip-to-chip. So that 2.5 seconds times 12 extra
seconds
tool
or
changes
something.
was
Yeah,
right
half a
around
minute.
30 seconds of
Right.
cycle time on something that ended up being, I think our time was 18 minutes roughly. So it wouldn't have saved me a lot of time in the cycle, but it sure would have cost me a lot of time in the setup to try to do Tool 1. Now, if I was going to make these parts on that machine every day for a year, thousands and thousands and thousands, it might have been worth the time for me to go in and do all that editing to run Tool 1 on all of the vices. But
Or maybe just have 2
with a
versions of the
100-piece
part.
lot, it was definitely going to take too much time.
Right.
Yeah, makes sense.
There's
Yeah,
2
it's all about
versions of
lot
the
size.
program. You've got your kind of your setup program, and
Yeah.
then your actual like production run program.
Yeah,
Right.
exactly.
Yeah.
Now you got to manage 2 programs, and yeah,
Wasn't worth it. The cycle time savings wasn't worth it.
no.
One of the things that people often talk about, one of the benefits of 5-axis or a 5-axis machine like this is not having to reposition this part 5 times in these vices, and so that potentially gives you additional accuracy, or at least it gives you less opportunity for error.
Yes.
Maybe we want to talk about that a little bit.
Yeah, and I mentioned it in the video. Every time you handle the part and load it in work holding, you have the potential to load it incorrectly, to get the part trapped, a chip trapped between the part and the work holding, something that might go wrong. So that is definitely a benefit to 5-axis machining and performing more operations and only holding onto the part one time. It's going to be more accurate, and you're going to have less chance to make an error loading the part.
Right.
Absolutely, no
And
question.
like whatever, if you've got a datum here and a datum here, you're just more likely part to part to hold that exact, because it's all just machined in.
Yeah.
Versus
Yeah.
maybe I have that's op 4 and this is op 5, then the potential for having a
Yeah,
problem.
it could be misloaded on one, or you may get a dimension that ends up floating around because it's not being located as rigidly in one of the setups. So that might end up causing you a problem. But having a nice rigid 5-axis work holding and rotating the part to machine all the features from the other sides, you're going to get a more consistent quality part.
Okay, so in the video, you talk specifically about chamfering this particular feature, this rib along here, and how in this machine you're able to orient that directly in the relationship you want it to the tool, to the cutting tool. Maybe
Yeah.
talk about that.
Yeah, sure. And this is something that you really couldn't do if you had it set up on a 4th-axis machine, because you can't get to that compound angle.
Right.
What I did is establish a compound angle, especially for this chamfer here and on this side of that rib. And the reason I did it is because the outside diameter of this feature comes right up to that edge. So I was able to set it so that chamfer angle is flat and come in with a flat end mill and just get that end mill to break that edge without cutting into that radius. Now, if you were on a 4th axis machine or in a 3-axis setup and you had to get a standard chamfer mill to cut that, you really couldn't, or it'd be very difficult to get next to this edge and also to this shoulder.
Yeah.
That's another thing I did. In this orientation, I took a flat end mill and just cut along here from both sides to cut this chamfer, and I did the same thing up here on that side. So I was able to utilize compound angles in the 5-axis machine to break sharp edges on 1, 2, 3, 4, 5, 6 different locations of this part. And that's stuff that I could achieve it, but it would have been more difficult, and I probably couldn't have gotten complete chamfers. In other words, I wouldn't have been able to chamfer right up into that sharp corner there with a standard 45-degree chamfer mill.
Tailed off just before you hit it and left a little section.
I think that speaks to some of what we've heard from a lot of our customers using UMCs and, of course, 5-axis in general, is that part to part, going from a 3-axis setup to a 5-axis setup, it just makes it easier to do a lot of things. You just have to put less brain power into doing a lot of these things on this kind of a machine than you do on the other. It's not that you can't do it. It's just things that were kind of a big leap previously now become kind of second nature and are just easy to take care of.
Yeah. Once you understand some of the things that you can do, these are techniques that you can use all the time on a lot of different parts to actually make your life a lot easier and get the parts to come out better as well.
So that's an example of something that is going to take you a little while to learn, perhaps on a 5-axis machine, is these like little tricks and ins and outs of using all the features here versus on this other machine you're probably more used to.
Yeah, more so understanding the concept and then keeping that in the back of your mind whenever you're planning a job. Oh yeah, I can hit that. I can set up a compound angle and cut that with a flat end mill instead of a chamfer mill. That's just something that you learn, hopefully on your first foray into the 5-axis world, and then you take it with you to each job that you do, for sure.
We were talking off camera earlier, and you were saying that always there's things that you could have done that you only realize later, or there's probably 50 different ways to do some of this stuff, and that's kind of what's cool about machining anyway. There's usually a lot of ways to do it, but.
Yeah, you have to decide on which one you think is best for you at the time. And as you grow and get more gray hair, more experience, you definitely pick up these tricks along the way, and it's just the evolution of the process.
So I think we're starting to wrap up here a little bit. I'm wondering, because we talked back and forth a lot about the comments. And what were your thoughts on the comments? Because we got a lot of them.
Yeah, that was the first thing that struck me was how many we had. In the first, 4 hours it was up, there was 20 or more comments. And as I was reading through them, there were a couple that I was like, I mentioned earlier, cutting the stock into a triangle on a saw. I was like, oh, geez. I never thought it might have worked, huh? Okay, yeah, that's pretty good. And the first thing that struck me was people were saying, one of the first comments was, oh, it's not fair to use the price of the vises and all this, and my first thought was, this person kind of missed the point. And maybe it's because we didn't make the point more clear that we were just comparing how you would do this on a 3-axis machine and on a 5-axis machine, and we wanted to be upfront about what it was going to take to do that, and we addressed the cost of those 5 vises earlier. But that was one of the first things that struck me. But the other thing was that there were some really good ideas in there, things that I hadn't thought about, cutting into a triangle, and I didn't consider how I would make it on a 4th axis. That's not what we talked about. The subject of the video was going to be, but as I thought more about it, well, yeah, that would work out. I'd have a difficult time with compound angles, but I would have figured some way to get those done.
That's always one of the questions we're trying to balance is how much do you show, you know?
Yeah.
We don't want to, we're usually not heading out to make like a 30 or 45-minute video about how you'd make it on a 3-axis setup, 4-axis setup, and a 5-axis. It just gets unwieldy at some point.
Yeah.
Right.
But for sure, those comments are very useful.
And to your point, that's why we're making this video as a follow-up to that one. That video could have been an hour and a half if we'd have really, you know, covered every aspect of it.
Well, and I think, you know, we've talked about, and I hope we find time to do it, is going over to the VF4, putting your setup back on, which I know you're looking forward to.
Yeah.
But really talking through that, because we did have a lot of comments, and I don't remember them specifically, I'm paraphrasing, and said, oh, there's no way, you didn't need 5 vices to do that. And maybe there's a different way to do it. I mean, like you said, you had some great ideas in the comments, but
Yeah.
we want to talk through why you did what you did, and I think it'll make a lot more sense to the viewer, because we did gloss over some of that just for video length, so it wasn't a 45-minute video.
Yeah.
Yeah, we shot, I'm sure, you must have shot 20 hours of footage over there at that machine, just in terms of the demo and all the different setups.
Yeah, and different camera angles and that kind of stuff. So I'm not sure what the total runtime of that video would have been, but yeah, it definitely, you know, all of these videos need to get edited down to be concise and watchable.
I mean, one of the things, you know, I made light of some of the comments a little bit, but we truly do, we leave all the comments in there. There's a few that have to be deleted for obvious reasons, language and such, but we really do look at the comments, we discuss them, especially for a video like this, and in some cases they actually give us some good ideas.
Yeah, yeah. I really feel that we're lucky to work at a company that is so open and honest about everything that we're doing. It's fantastic. I mentioned to you earlier, I can't believe we get paid to do this.
I know. It's tempting to remove some of those comments, but yeah, we leave them in. We really do learn things from some of them. And even though we may not like every single one of them, they're valuable.
Yeah, yeah. And the ones we don't like probably hit home the hardest. All right, guys, thank you very much for coming in and doing this. Thank you for joining us and watching. If you like this kind of video, the follow-up to videos that we produce, say that in the comments, and maybe we'll put together more of these in the future. Hopefully we'll get around to doing a in-depth on the 3-axis version. We'll take a closer look at the setup. So watch for that video in the coming weeks. Thank you very much.
Thanks, guys.
See you next time.